Migraines. Just hearing the word can send shivers down your spine. We often think of them as really bad headaches, but migraines are much more than that. They are complex neurological events, like a sudden storm brewing inside your brain. Imagine this. You're going about your day when suddenly you see flashing lights. Your vision blurs. Then a throbbing pain explodes on one side of your head. You might feel nauseous, dizzy, even sensitive to light and sound. This is the reality for millions of people who experience migraines. But what's really going on in the brain during a migraine? Scientists are piecing together the puzzle, uncovering a fascinating interplay of nerves, chemicals, and blood vessels. This is a journey into the science of migraines, where we'll explore the intricate mechanisms at play and the latest discoveries paving the way for better treatments. One of the key players in the migraine drama is a phenomenon called cortical spreading depression, CSD. This is a complex process that plays a significant role in the onset of migraines. Imagine a wave, but instead of water, it's a wave of disrupted brain activity. This wave is not just a simple disturbance, it's a profound shift in how the brain functions temporarily. This wave, CSD, travels across the surface of the brain, like a ripple in a pond. It moves slowly, affecting different regions of the brain as it progresses. As CSD spreads, it disrupts the normal electrical activity of brain cells. This disruption is significant because it alters the way neurons communicate with each other. This disruption can cause a range of symptoms, from visual disturbances like flashing lights or blind spots, which are often the first signs of an impending migraine, to tingling sensations in the face or limbs. These sensory changes can be quite alarming and uncomfortable for those experiencing them. Think of it like a temporary electrical short circuit in the brain. This short circuit interrupts the normal flow of electrical signals, causing a temporary malfunction. This short circuit doesn't cause any permanent damage, but it does disrupt normal brain function, leading to a temporary but significant impact on the person's well-being, leading to the sensory disturbances that characterize the migraine aura. These auras are warning signs that a migraine headache is likely to follow. CSD is a crucial piece of the migraine puzzle because it is thought to trigger the cascade of events that ultimately lead to the debilitating headache phase. Understanding CSD is key to understanding migraines. Now, let's talk about pain. Migraines are infamous for their intense throbbing pain, often concentrated on one side of the head. This pain is not just in your head. It's a signal, a message being sent from your brain to the rest of your body. The messenger responsible for delivering this pain signal is the trigeminal nerve. This large nerve is like a major highway for pain signals from the head and face. When CSD disrupts brain activity, it can activate the trigeminal nerve. This activation triggers the release of chemicals, like neurotransmitters, that transmit pain signals to the brain. Imagine a fire alarm being tripped. CSD is like someone pulling the alarm, and the trigeminal nerve is the alarm system itself, sending out the urgent message of pain. Section 4. Cerebrospinal fluid, the brain's liquid cushion. The brain is a delicate organ, floating in a protective cushion of fluid called cerebrospinal fluid, or CSF. This fluid is essential for maintaining the brain's health and functionality. This fluid acts as a shock absorber, protecting the brain from injury. It cushions the brain against sudden impacts and movements, ensuring that the delicate neural tissues remain unharmed. But recent research has uncovered a surprising link between cortical spreading depression, or CSD, and changes in CSF. CSD is a wave of electrical activity that spreads across the brain, often associated with migraines. It turns out that CSD can alter the composition of CSF, making it more acidic. This shift in acidity is significant because it can affect the brain's overall environment. This change in acidity can trigger the release of inflammatory molecules that further activate the trigeminal nerve, amplifying the pain signals. The trigeminal nerve is a major pathway for transmitting pain signals in the brain. Think of it like this. Imagine dropping a tablet into a glass of water. The tablet dissolves, releasing substances that change the water's composition. The tablet dissolves, changing the composition of the water. This is similar to how CSD changes the composition of CSF. Similarly, CSD alters the delicate balance of CSF, leading to a cascade of events that contribute to migraine pain. This imbalance can have far-reaching effects on brain function and health. This discovery opens up exciting new avenues for migraine treatment, focusing on ways to restore the normal balance of CSF and dampen the inflammatory response. By targeting the root cause, we can potentially alleviate the debilitating pain associated with migraines and improve the quality of life for sufferers. Section 5. Blood vessels in the brain. A delicate dance. Now, let's shift our focus to the intricate network of blood vessels in the brain. These vessels are responsible for delivering oxygen and nutrients to brain cells, keeping the brain functioning properly. During a migraine, these blood vessels can behave erratically, constricting and dilating abnormally. This vascular reactivity is thought to contribute to the throbbing pain characteristic of migraines. Imagine a garden hose with kinks in it. The water flow becomes restricted and uneven. Similarly, the constricted blood vessels in the brain during a migraine disrupt the normal flow of blood, leading to pain and other symptoms. Section 6. CGRP, the migraine molecule. In recent years, scientists have identified a key player in the migraine drama, a molecule called calcitonin gene-related peptide, or CGRP. This peptide is involved in pain signaling and blood vessel regulation. During a migraine attack, levels of CGRP surge in the brain. This surge is thought to contribute to both the neurological and vascular changes that occur during a migraine. Think of CGRP as the conductor of the migraine orchestra, coordinating the different instruments, nerves, blood vessels, and inflammatory molecules, to create the symphony of pain and other symptoms. This discovery has revolutionized migraine treatment, leading to the development of a new class of drugs that specifically target CGRP, blocking its action and providing relief from migraine pain. Section 7. New Horizons, latest research and treatments. The good news is that scientists are making significant strides in understanding and treating migraines. With each passing year, new breakthroughs are being made that bring us closer to effective and lasting solutions. One promising area of research is early intervention. This approach focuses on identifying and treating migraines at the earliest possible stage. Studies have shown that treating migraines early, during the aura phase or even before the headache starts, can significantly improve outcomes. This proactive approach can prevent the migraine from fully developing, reducing both the intensity and duration of the attack. This is where new medications, like CGRP receptor antagonists, come in. These innovative drugs are designed to block the activity of a protein involved in migraine attacks. These drugs can effectively stop migraines in their tracks, especially when taken at the first sign of an attack. They offer a new hope for those who suffer from frequent and severe migraines. Furthermore, researchers are exploring ways to target the trigeminal nerve pathway more precisely, aiming to block pain signals without affecting normal nerve function. This could lead to treatments that are both more effective and have fewer side effects. The future of migraine treatment is also moving towards personalized medicine, tailoring treatments to individual patients based on their unique triggers, symptoms, and genetic makeup. This individualized approach promises to improve the effectiveness of treatments and reduce the trial and error process that many patients currently face. The journey into the science of migraines is ongoing, but with each new discovery, we move closer to a future where migraines are no longer a debilitating mystery, but a manageable condition. The hope is that one day, migraines will be a thing of the past, thanks to the relentless efforts of researchers and medical professionals.